This lesson is on simplifying radicals with variables. So the first step is going to be to simplify the number using prime factorization. The second step is going to be pertaining to the variables. And what you're going to do is divide the exponent by the index. The whole number goes outside the radical. The remainder goes inside the radical. So let's look at an example. So the first thing I'm going to do is the prime factorization of 32. So that's going to be 2 and 16, 2 and 8, 2 and 4, 2 and 2. And I have an index of 2, so I need them to be in groups of 2 in order to break free from that radical. So I'll have 2 times 2 on the outside from this group and this group. And I'll have 1, 2 that has to stay on the inside. Now for the variables, I'm going to deal with the x first. So I'm going to divide the exponent by the index. Well, that's just x squared, and there's no remainder. So that x squared is going to go on the outside. Then I'm going to deal with the y, and I'm going to divide the exponent by the index. And that's 4 with a remainder of 1. So that's going to be y to the 4th and y to the 1st. That y to the 4th is going to go on the outside, and the remainder, y to the 1st, will go on the inside. Now I can simplify. Well, 2 times 2 is 4 times x to the 2nd times y to the 4th. And what's left inside the radical is 2y, or 2y to the 1st. And this is your answer. Let's look at a different one. So the first thing I'm going to do is the prime factorization of 324. And if I divide by 3, I get 108. I can divide by 3 again and get 36. I can divide by 3 again and get 12. I can divide by 3 again and get 4. And then I would end up with 2 and 2. My index is 2, so I'm going to need these 3's in groups of 2. And also, I will need the 2's in groups of 2. And everything works out. So I'll have 3 on the outside of my radical. I'll have 3 times 3 times 2. And now it's time to deal with the variables. So for A, I'll have 3 over 2, which is 1 remainder 1. So I'll have a to the 1st on the outside and a to the 1st on the inside. Then I'm going to deal with B. So 7 divided by 2 is going to be 3 remainder 1. So I'll have b to the 3rd on the outside, b to the 1st on the inside. So when I simplify, 3 times 3 is 9, times 2 is 18, ab cubed times the square root of ab. And that will be my answer. Now we can look at a couple that have a different index. So my prime factorization here with 216 can be 3 and 72, 3 and 24, 3 and 8, 2 and 4, 2 and 2. I need them in groups of 3 because my index is 3. So on the outside of my radical, I'll have 3 times 2, and now it's time to deal with my variables. Well, for m, it's exponent over index, which is just 1. So my m to the first will go on the outside. For n, it's 6 over 3, which is just 2. So n to the second goes on the outside. So I actually don't have anything left on the inside for this. So I won't have a radical. This will just become 6 m to the first, n to the second. Now looking at number 12, my prime factorization. I'm going to divide by 2, and that's 28. Divide by 2 again, and that's 14. Divide by 2 again, and that's 7. Now I need everything in groups of 3 because my index is 3. So I'll pull 1, 2 to the outside, and a 7 will stay on the inside. Now I can deal with my variables. So divide the exponent by the index, which is 2, remainder 2. So that'll be r squared on the outside, r squared on the inside. Then for s, divide the exponent by the index, and that's 1, remainder 1. So that's s to the first on the outside, s to the first on the inside. So my answer would be 2r squared s times the square root of 7r squared s. Here I'm going to do another prime factorization, and I know that what I pull out is going to end up being negative. So if I do negative 2, that's 32. Another negative 2, that's 16. And so on. I need them in groups of 3. So outside of my radical, I'll have a negative 2 and a 2. For inside, I'll have 10 divided by 3, which is 3 remainder 1. So I'll have x cubed on the outside, x to the first on the inside. For y, I'll have 21 over 3, which is just 7. So I'll have y to the 7th on the outside. So my final answer will be negative 4, which is the cube root of negative 64, x cubed y to the 7th times the square root of x. I'm sorry, the cube root of x. Now we'll try this one. So I'll pull out 3 and 27, 3 and 9, and 3, and 3. And because this is a cube root of a negative number, I know what's on the outside will have to be negative. So I'm going to pull out one group of those 3's. So on the outside, I'll have a negative 3. And really what we've done is we've factored in that negative just one time, and the rest of them are positive. But I'm going to pull out a negative on the outside of my radical, and I'll have a 3 on the inside. For P, it'll be 2 over 3, which I can't divide. So then my P squared will just stay on the inside. For Q, it'll be 12 over 3, which is 4. So Q to the 4th will go on the outside. So my answer is negative 3 Q to the 4th times the square root of 3P squared. I'm sorry, the cube root. The next one we're going to look at is a 4th root. Now this one doesn't have any constants, so all we have to worry about is the variables. So 4 over 4 is just 1, so W to the 1st will go on the outside of the radical. And V, 17 over 4, is 4 remainder 1, so V to the 4th will go outside, V to the 1st will go inside. So then my final answer is W times V to the 4th times the square root of, or the 4th root of V. The next problem is also a 4th root, but has a constant. So I can divide that by 2, get 24, by 2 again, get 12, by 2 again, get 6, by 2 again, and get 3. And I need a group of 4 because the index is 4 to break it out. So outside the radical, I'll have a 2, and inside the radical, I'll have a 3. For M, I'm going to divide that exponent by the index, and I get 2. So M squared will go on the outside. For N, I'll have 3 over 4, which can't be divided with a whole number, so that N to the 3rd just stays on the inside. So the answer here is 2M squared times the 4th root of 3N cubed. We'll start with 625 on this one. And I'm going to divide by 5, get 125, divide by 5 again, and get 25, divide by 5, and that's 5 and 5. And I need 4 of them to break it out. So that's going to work out perfectly. And I know that the 4th root of 625 is just 5. Now for C, I'll have 23 over 4, which is going to be 5 remainder 3. So I'll have C to the 5th on the outside and C to the 3rd on the inside. And for D, I'll have 11 over 4, which is 2 remainder 3. So I'll have D squared on the outside and D to the 3rd on the inside. So my final answer is 5C to the 5th D squared times the 4th root of C cubed D cubed. And our last example problem is actually involving a binomial. So what we're going to do is we're going to treat this whole thing like one variable. And what I'm going to do is I'm going to divide the exponent by the index, which gives me 2. So I can eliminate the radical altogether. So I'll have y plus 3 squared as my final answer. And if I FOIL that, I get y squared plus 6y plus 9 as my final answer.